If we're trying to find the equation for the tangent to a curve at a given point, we're going to need three things. We're going to need the coordinates of the point. That means x and y, and we're going to need the gradient of the tangent. Now, the gradient of the tangent is simply the derivative dy by dx. So the gradient m is simply dy by dx at the point that we're given, x equals 4. So that's one thing that we're going to need to find. We also need to find the value of y1, or the y coordinate for this. So let's do that first. Let's put 4 into our expression for y and find how much y1 is. So y1 is ln 5 minus 4 plus 2 times 4 squared. So ln 1 is 0, and there you have 16 times 2 is 32 over 17. So y1 is 32 over 17. So we can label this point as 32 over 17. So that's the easy bit out of the way. Now we need to find the gradient, dy by dx. Right, so to find dy by dx, if you look at this, it looks like it's a quotient. So we're going to need, so as part of the quotient rule, we would definitely need to differentiate this numerator. So let's start with that. So let's try to differentiate this numerator. So if we call that u ln 5 minus x plus 2x squared, then the derivative of u is negative 1 over 5 minus x plus 4x. Now the derivative of ln is 1 over x, but because of the chain rule, we multiplied by the derivative of 5 minus x, which happens to be negative 1. So that there is a result of the chain rule. So this negative comes about because of the chain rule. So that was the numerator. Now for the denominator, x squared plus 1. If we differentiate that, then that's straightforward. It's going to be 2x. So let me write that out. So v equals x squared plus 1. So v dash is 2x. And just as a reminder of the quotient rule, y dash will be u dash v plus uv dash, minus, divided by v squared. So that's the quotient rule. You're probably given that in the exam. You're almost certainly given that in the exam. So now we can write dy by dx equals, let's start with the denominator. It's simply x squared plus 1 squared. And then it's u dash times v, so it's 4x minus 1 over 5 minus x times v times x squared plus 1 minus uv dash. So v dash is 2x. I'm going to multiply that by u, which is 5 minus x plus 2x squared. Okay, so that's my expression for dy by dx. And what we want is the value of dy by dx at the point where x equals 4, because that's what we're being asked for. We're being asked for the equation of the tangent where x equals 4. So I need dy by dx at x equals 4. So let me substitute 4 at every point where we have an x. So we're going to have a 4 here, and here, and here, 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 and here. So let me put a 4 here, 4 here, 4 here, 4 here, and a 4 here, and finally a 4 here. And you can calculate that yourself. So that gives me negative 1 over 289. So that's the gradient of the tangent. So now we know the gradient, we can write the equation of the tangent using the coordinates of the point and the gradient. So y minus y1 equals m times x minus x1. So m is what we've just found. y1 and x1 we found earlier. So x1 is given in the question as 4, and y we found as 32 over 17. So that's 32 over 17, and that's 4. So you can say y minus 32 over 17 equals negative 1 over 289 times x minus 4. You can probably multiply everything by, let's multiply by 289. So 289 divided by 17 is 17. So that gives you 289y minus 17 times 32, 544, equals negative x minus 4. Now you simply expand the brackets and rearrange. So you have 289y minus 544 equals negative x plus 4. So we can write it as x plus 289y minus 548 equals 0, because you want to bring this 4 to that side. And that is now the equation of your tangent. That's your final answer. That's the equation of your tangent at the point x equals 4.